Our planet, a world dominated by vast oceans, holds hidden beneath its surface a network of powerful forces. Ocean currents, the unseen highways of our planet's oceans. They govern weather, shape ecosystems, and connect continents. From the deep, icy waters of the poles to the warm, sunlit tropics, these currents influence everything from climate to marine life. Let's explore the fascinating world of ocean currents.
Ocean currents are the lifeblood of our oceans, a continuous movement of water crucial to our planet's balance. These currents are like the veins and arteries of the ocean, circulating water and distributing essential elements across the globe. They are a continuous movement of water crucial to our planet's balance. Without these currents, our oceans would be stagnant, and marine life would struggle to survive. Imagine vast rivers flowing beneath the waves, driven by wind, temperature, and salinity. These invisible rivers are constantly on the move, shaping the marine environment in ways we are only beginning to understand. Driven by wind, temperature, and salinity, these currents create a dynamic and ever-changing underwater landscape. The interplay of these forces determines the direction and strength of the currents, making each one unique. These currents transport heat, nutrients, and life across vast distances. They are the highways of the ocean, carrying everything from tiny plankton to massive whales. They follow distinct patterns, influenced by a complex interplay of forces. The patterns of these currents are like fingerprints, each one telling a story of the forces that created it. Some currents, like the Gulf Stream, are rapid and powerful, moving warm water from the equator towards the poles. This not only affects marine life, but also has a significant impact on the climate of coastal regions. While deep ocean currents move slowly but profoundly, they play a crucial role in regulating the Earth's climate by redistributing heat and carbon dioxide. The sun, wind, and Earth's rotation all drive this aquatic ballet. The energy from the sun heats the water, creating temperature differences that set the currents in motion. Wind patterns and the rotation of the Earth further influence their paths. From plankton to whales, ocean life depends on these currents. They provide a steady supply of nutrients, making them essential for the survival of countless marine species. They carry nutrients to the surface, fuel phytoplankton growth, and regulate Earth's climate. Phytoplankton, the tiny plants of the sea, form the base of the marine food web and are vital for the health of the ocean. Join me as we unlock the secrets of these underwater highways. By understanding ocean currents, we can better appreciate the intricate and delicate balance that sustains life on our planet.
What sets these immense bodies of water in motion? The answer lies in a fascinating blend of natural forces that work together to create the dynamic and ever-changing ocean currents we observe. It's a delicate interplay of forces, each contributing in its own unique way to the movement of water across the globe. Wind is a primary driver, creating surface currents that flow with prevailing winds. These winds, blowing consistently over the ocean's surface, transfer their energy to the water, pushing it along and forming currents that can travel vast distances. Gravity, through tides, also plays a crucial role. The gravitational pull of the moon and the sun causes the water to bulge out in the direction of these celestial bodies, leading to the rise and fall of tides. The moon's gravitational pull is particularly significant, creating high and low tides that drive currents globally. These tidal currents are essential for the mixing of ocean waters and the distribution of nutrients. The Coriolis effect, due to Earth's rotation, adds a twist to current movements. As the Earth spins, it causes moving water to veer to the right in the northern hemisphere and to the left in the southern hemisphere, creating spiraling patterns in the ocean. Water flowing from the equator to the poles curves due to varying rotational speeds. This effect is more pronounced at the equator, where the rotational speed is highest, and diminishes as you move towards the poles. The sun's energy drives convection currents, with warm water rising and cold water sinking. This process, known as thermohaline circulation, is crucial for regulating the Earth's climate and distributing heat around the planet. These forces, wind, gravity, Coriolis effect, and solar heating, create intricate ocean current patterns. Each force interacts with the others, resulting in a complex and dynamic system that is constantly in motion. It's a testament to our world's interconnectedness. Ocean currents not only transport water but also carry nutrients, heat, and marine life, linking different parts of the ocean and supporting diverse ecosystems. Together, they form a complex and vital system. Understanding these driving forces helps us appreciate the intricate balance of our planet's oceans and the life they sustain.
Ocean currents are diverse, forming a tapestry of unique flows. Broadly, they are surface currents and deep currents. Surface currents occur in the ocean's upper layer, driven by wind. They influence weather patterns and create ocean gyres. Trade winds push surface waters, forming currents like the Gulf Stream. Deep currents hidden from view are driven by water density differences. Cold, salty water sinks, creating slow-moving deep currents. These deep currents are part of the global ocean conveyor belt, transporting heat and nutrients. The interplay between surface and deep currents maintains a delicate balance. Understanding these currents is crucial for comprehending ocean dynamics.
Our journey now takes us to significant ocean currents shaping our planet. The Gulf Stream, a warm current, moderates Western Europe's climate. Without it, regions like Ireland would be much colder. The Humboldt Current, a cold current, supports a productive marine ecosystem off South America. Its nutrient-rich waters sustain vast marine life. The Antarctic Circumpolar Current, the largest, connects the Atlantic, Pacific, and Indian Oceans. The Kuroshio Current, a warm current, influences Japan's climate. These currents are essential to our ocean's health and humanity's well-being.
Ocean currents impact every aspect of life on Earth. These powerful flows of water, driven by wind, salinity, and temperature differences, are the lifeblood of our planet's oceans. They regulate our planet's climate, transporting heat from the tropics to the poles. This heat transfer is essential in maintaining the delicate balance of our global climate system. The Gulf Stream, for instance, warms Western Europe, making it more temperate than other regions at similar latitudes. Conversely, cold currents like the Humboldt Current cool regions, creating unique ecosystems and weather patterns. Currents support marine life by carrying nutrients to the surface, fueling phytoplankton growth. These tiny organisms form the base of the marine food web, supporting a vast array of sea life. They influence fish migration, providing feeding and breeding grounds. Many species of fish and marine mammals rely on these currents to guide them to their seasonal habitats. Human activities like shipping and fishing rely on ocean currents. The movement of goods across the globe is facilitated by these natural pathways, making trade more efficient. Shipping routes use favorable currents to reduce travel time and fuel consumption. By harnessing the power of these currents, ships can travel faster and more economically, reducing their environmental footprint. Currents also affect the spread of pollutants, crucial for oil spill response. Understanding how these currents move can help in predicting the spread of contaminants and in planning effective cleanup operations. Understanding ocean currents is vital for addressing climate change and marine conservation. Scientists study these currents to predict changes in climate patterns and to develop strategies for protecting marine ecosystems. These unseen highways shape our world in profound ways. From regulating climate to supporting marine life and human activities, ocean currents are a fundamental force of nature that we must continue to study and understand.
Imagine a vast, interconnected system of ocean currents linking the world's oceans. This is the global ocean conveyor belt, regulating Earth's climate and sustaining marine life. It begins in the North Atlantic, where cold, dense water sinks and forms a deep current. This current travels to the Southern Ocean, where it rises, bringing nutrients to the surface. Surface currents carry warm water northward, completing the cycle. This system distributes heat and absorbs carbon dioxide, regulating Earth's climate. The global ocean conveyor belt is a testament to our planet's interconnectedness.
The world of ocean currents is filled with fascinating phenomena. The Antarctic Circumpolar Current circles the globe without encountering land, mixing ocean waters. The equatorial countercurrent flows eastward, opposite to trade winds. Ocean currents transport immense volumes of water, like the Gulf Stream's 100-fold flow compared to all rivers combined. These currents reveal the hidden wonders of our planet's circulatory system. They continue to amaze and inspire us.
Understanding ocean currents is crucial for our planet's future. Climate scientists use current data to predict climate change impacts. Marine biologists track currents to study marine species and develop conservation strategies. Oceanographers monitor currents with advanced instruments, creating maps and models. Understanding currents helps predict pollutant movement, aiding cleanup efforts. The study of ocean currents involves multiple scientific disciplines. By working together, scientists unravel the mysteries of these underwater rivers. This knowledge is essential for addressing global challenges and ensuring a sustainable future.
Chapter 10. The Pulse of Our Planet. Ocean currents, nature's mighty rivers, link every corner of our blue planet. They are the lifeblood of our oceans, carrying warmth, nutrients, and life itself across vast distances. By protecting and understanding them, we protect the future of life on Earth.